So in this given circuit, AC source has an omega of 100 radian per second. Considering the inductor and capacitor to be ideal, what will be the current I flowing through the circuit? I flowing here, so here let it be I1, let it be I2. We have to find the resultant of I1 and I2. இங்கே capacitor இருக்காரு, இங்கே inductor இருக்காரு. Okay, so here your I vector is nothing but I1 vector plus I2 vector. We have to treat the currents as vector, because here phase difference between voltage and current will be different. Here phase difference between voltage and current will be different. First we can analyze this circuit. So here you have an RC circuit. Okay, so this is 100 microfarad C and this is R. In RC circuit, let me find what is the current flowing through this. So before entering into this, let me find what is your XC. Okay, I know the potential difference between these 2 points is nothing but 200 volt. So here this is nothing but 200 volt. Up here your XC is nothing but 1 by omega C. So 1 by omega is 100. So 10 to the power 2 into C is 100 microfarad. So 10 to the power 2 into 10 to the power minus 6. So what we will get? 1 by 10 to the power minus 2, which is nothing but 100. So here your Z is nothing but total resistance of the circuit is nothing but XC square plus plus R square plus XC square. So this we will get it as, okay, 100. This is 100, am I right? Yes, this is 100. So this is nothing but 10 to the power 4 plus, again if you square this, 10 to the power 4, we will get root 2 10 to the power 2, which is nothing but 100 root 2. Then what will be the current flowing here? So that we have to find. So current flowing here is nothing but V by Z. V is nothing but 200. 200 by Z is 100 root 2. So we will get root 2 ampere as the answer. Here if you see, okay, here in this circuit current flowing is constant. So let me draw the phasor diagram for that. So let me represent the current in the x-axis, okay, because it is constant in this. Over here voltage across the resistor will be in phase with the current, but here if you see the voltage across the capacitor, how it will be? Okay, so the voltage in the capacitor will be lagging. Okay, in the capacitor your current, okay, your current will leads by 90 degree. Apo your voltage will lag by 90 degree. Apo here I can draw the voltage across the capacitor. Okay, here this angle is 90 degree. Okay, this is what we know. Apo here if we have like this, so voltage in the resistor is nothing but your I into R. I we know root 2. Okay, R we know 100. So here you will be having 100 root 2. Same like that here, V is equal to XC into your current. Upon current we know it is root 2. XC is what? XC is 100. Upon this is 100 root 2. Upon both the values are same. So here your resultant will be equal to what? Here this will be 45 degree. This will be 45 degree. Your resultant is nothing but this root 2 ampere. Okay, this root 2. So here the angle between the current and the resultant voltage is 45 degree. Same like that if you do for inductor. Okay, if you do for inductor, your Z, here you have inductor and resistor. Okay, so you have inductor and resistor. So this is 50.5. So 50 ohm, this is 0.5 Henry. So here your Z will be equal to root of your XL square, which is nothing but 100 into 0.5 square plus 50 square. So here you will get 50 square plus 50 square. This is nothing but root 2 into 50, which is nothing but 50 root 2. So here current will be equal to what? We wrote this as I2. So your I2 will be equal to what? V by total Z. V is again 200. So it is 200 by 50 root 2. Cancel it, cancel it. Here you will get 4, we will get 2 root 2 ampere. Okay, so we are getting 2 root 2 ampere. Here if you draw phasor diagram for this, what we will get? So here current is flowing here, voltage across the resistor here. In inductor your voltage will lead by 90 degrees. So here you will be having your voltage across the inductor. Here if you see the, okay, here if you see the current 2 into root 2, what will be the voltage in the inductor? Sorry, resistor. Voltage in the resistor is nothing but I into R. About 2 root 2, it is 2 root 2 into 50. So again we will get what? 100 root 2. Same like what we got in before case. This is 100 root 2. What will be the voltage across the inductor? This is nothing but I into XL. I is what? 2 root 2. So 2 root 2, XL is 0.5. Alright, yeah, 2 root 2, XL is 0.5 Henry. Here if you do, what we will get? 0.5 into 2 is nothing but root 2. Okay, about the current voltage across the inductor is root 2 voltage we are getting. Now instead of XL I substituted L. Sorry, here XL is what? Your 50. Okay, so here we will get again 100 root 2. So this is 100 root 2. So 100 root 2, 100 root 2. Here your resultant will be your 2 root 2 ampere. And here the point is, here this angle is also 45 degree. Okay, this is what the point is. So here this is 2 root 2. Okay, so now if you find the resultant of this two current, okay, here the angle between them is 90 degree. Apo your total current flowing in the circuit is root of I1 square plus I2 square. Here this cos 90 will become 0. So this is root of your 2 root 2 whole square, okay, plus your root 2 whole square. So here this is actually root of 4 into 2 plus 2. So here we will get 8 plus 2 root 10. So root 10 we will get, it is nothing but pi. Okay, 3.14. So your answer is not there. Your answer should be 3.14 ampere.